All right, class. Excited to teach about factoring polynomials. This is my favorite subject. So this covers 3 different sections in our specific class. It's 5.5 to 5.7. In the future, these sections might change, but basically this is factoring polynomials. I'm going to do these by category and then do an overall one. So there'll be multiple different smaller videos showing each kind of factoring that you'll encounter. This first video is going to be about identifying the GCF. GCF stands for greatest common factor. Greatest means the biggest. Common means that you have to have more than one term. And factor means we're talking about numbers that can be multiplied together to get the number that you're given. Okay, so we're talking about numbers that are smaller than the number that you're given or no larger than the number itself. Okay, so it kind of seems backwards, but again, you can think of this as the biggest small thing instead of the smallest big thing. Okay, not to be confused with the LCM. So the couple things that you'll be asked to do here as far as greatest common factor. First of all, why is greatest common factor important? Well, it's the first step to factoring. It's not the only step, but we have to learn how to do it before we can factor other polynomials. So first step to factoring is factoring out the GCF. You need to then count the number of terms, and then we're going to check for nesting. And again, we'll get through each one of these steps, but for now we're just focusing on step 1. And this is in section 5.5 in our book. First thing that I want to talk about is, what does prime mean? When you say a polynomial is prime, it means that it cannot be factored, or it's not factorable. And remember, if you have a GCF and you take a GCF out, you have factored the polynomial. So a GCF counts as factoring. So you can't say that a polynomial that has a GCF is not factorable. Okay. Another thing you want to remember is that if you have a leading coefficient or a leading negative coefficient, let me say this, a negative leading coefficient, excuse me, negative leading coefficient, then you need to factor out a negative. So what would that look like? Well, if I had like a negative 8x squared plus a 4x minus 2, then I would say the GCF is 2, but I'd factor out a negative because the first, or the largest exponent term is negative. Okay, so that's what I mean by a negative leading coefficient. Okay, so let's rewind for just a second and talk about how we identify the greatest common factor. Well, to identify the greatest common factor, you factor the terms that you're given. So notice that these are separated by a comma, not addition or subtraction. And what we're going to do is we're going to say, okay, well, 24 factors down to 4 times 6, which factors down to 2 times 2 and 2 times 3. 4 factors down to 2 times 2. 16 factors down to 4 times 4, which is 2 times 2 times 2. So I'm just looking at the constant right here for now. And basically I'm saying, what is the biggest number that can go into all 3 of these? Well, 4 can't have something go into it evenly or come out as a whole number. Nothing bigger than 4 can go into 4. So the greatest common factor cannot be bigger than your biggest number. So when I'm looking at these and I want to say what they all share, I could say this has a 2, so does this, and so does this. So we know they all share a 2. They share a second 2 here. So they all share 2 times 2. Well, what else do they all share? This one has 3 x's related through multiplication. This one has 1 x, and this one has 2 x's. Well, they all share 1 x related through multiplication. If I'm looking at y's, this one has 2 related to multiplication, this has 2 y's, and this has 1. So they all share 1. Again, you can't have more in common than the smallest 1. Okay, so when you're looking at exponents on variables, you've got to just identify the smallest one. So what does this mean our GCF is? Well, this is everything they have in common. So this is the biggest thing they have in common is 4xy. So this is just identifying the GCF. Okay, another thing that you should know is sometimes you can look through terms, like this one has a 2, this one has a 5, and this one has 17. Well, 2, 5, and 17 are all prime. They have no common factors. Okay, so then I'm going to go to this A. This has an A, but this one doesn't, so they don't have that in common. Then I'm going to go to B. We've got a B here, no B here, so they don't have that in common. These two have a C, but this one doesn't. There's nothing here that they all have in common. So this one you would just say there is no GCF, basically, other than 1. They have nothing in common other than the factor of 1. So you can have a constant GCF, you can have a variable GCF, you can have both. So sometimes you might just have a constant, sometimes you might just have a variable, sometimes you might have nothing. So this is identifying the GCF. Okay, but most of our problems will say factor out the GCF. So how would I factor out the GCF? Well, to factor out the GCF, I'm going to do the exact same process we did here and say, well, if I look at all these different terms, remember that terms are separated by addition and subtraction. So I'm going to just circle the terms here so that we can see. There's 4 terms here, and I'm looking for something that they all have in common. So I look at 4, 6, 4, and 8. Well, they all have a common factor of 2. Because 4 and 6 aren't any further than 2 apart, they can't have 8 in common. Like I can't divide 6 by 8 and come out evenly. But I could divide 4 by 2 and get 2. I can divide 6 by 2 and get 3. I can divide 4 by 2 and get 2, and 8 by 2 and get 4. So the GCF here is going to be 2 for my constant. Then I'm going to go through and look at the A's. This one has A squared, this one has A, this one has A, and this one has A. So they all have an A in common. Now I'm going to go through and look at my B's. This one has a B squared and a B squared. This one doesn't have a B, so they don't all have it in common. Again, a GCF has to be in common between all of the terms. So now I'm going to go to my C. This one, and this one has a C, but this last one doesn't. So right here, this is my GCF. Okay, is 2A. But I'm not just asked to identify the GCF for this problem, I'm asked to factor it out. When you factor out a GCF, what you're actually doing is you're dividing every term by it. So my GCF here is 2A, but what I'm really doing is I'm dividing, might not be big enough, I'm dividing this term by 2A, and 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 I'm going to write those results here. Okay, so the result of dividing 4A squared B squared C by 2A is going to be 2A B squared C. So 4 divided by 2 is 2, A squared divided by A leaves me with an A, and then I have this B squared C. The result of dividing negative 6A B squared C by 2A is going to be negative 3, the A's cancel, B squared C. The result of dividing negative 4 AC by 2A, the 4 divided by 2 is going to give me 2, a negative 2. The A's will cancel and I'll have C left. The result here is going to be 8 divided by 2, which is going to give me a positive 4, and the A's cancel. So factoring out the GCF means identify it, put it out front, and then divide each of the terms by it to see what's left here. So I just always call this what's left. What's left inside of these parentheses. Okay, so that's factoring out a GCF. This one here, you can also have 2-term GCFs. So this is a 2-term GCF, which is totally fine. But here, you can look, and this right here is related to this through multiplication, just like this 4 is related to that A squared through multiplication. So I can literally look at these 2 terms, which I'm going to say this is 1 and this is 2. And I can say, oh my gosh, they both have an A plus Y. Okay, well, question is then, what is left here? Well, when I divide this term, just like we did over here, by a plus y, the a plus y's cancel, and I'm left with 8z. When I divide this term by a plus y, the a plus y's cancel, and remember that anything divided by itself is 1. So I don't have nothing here. I have a minus 1, and this negative, these cancel, leave behind a 1, but it's a negative 1. So this is a 2-term GCF here. Okay, so right here is the GCF, and here is what's left. Okay, so this is greatest common factor and factoring out the greatest common factor. So I want to come back to this one now that we've talked about what a GCF is. Now we identified 2 as the GCF here, and I've got to factor out a negative 2 because my leading coefficient here is negative. When I divide this, each of these by a negative 2, let's talk about what happens here. So I'm going to get a negative 8 divided by a negative 2 is going to give me a positive 4x squared. Okay, a positive 4 divided by a negative 2 is going to give me a negative 2x. Then some people will take this and be like, oh, all done. But no, remember that anything divided by 1 is itself. So this is a positive 1 inside of here. Another thing you should remember is that when you multiply this back out, you should get the result that you started with. So when I distribute, I get negative 8x squared, positive 4x, and a negative 2. You can see that I got what I started with. Another thing that you should remember is that if you have the GCF, if you look inside of here, these should have nothing in common. 4, 2, and 1 have no common factor. X, X, no X. There's no common factors, so you know you got the GCF. If we look inside of this one, we've got 2, 3, 2, 4. Those don't have anything in common. So I've got an A here, no A's here, we're good. B here, no B's here. C here, C here, C here, no C there. So there's no common factor inside. That's how I know that I've identified and factored out the GCF. So this is the first step of factoring polynomials, factoring out the GCF.